Okay, you just finished homework number 3, and you've got a little extra time for the next assignment. The next assignment you've got until Tuesday the 14th. So that's almost 2 weeks for this next one.
It's because it's harder?
It's because there's more topics on it. I don't think any one of the questions is particularly complex, but it's covering, instead of only 2 lectures, it's covering 3 lectures worth of material. Looking a little bit further into the future, you also have an exam coming up on Thursday the 16th. And so the schedule that I gave you that's accompanying the syllabus, you can see what are the entire list of topics that will be included on that exam. It's basically all of the material up through and including the lecture on Tuesday, February 14th. Oops, sorry. And then just the other thing that you've got on your plate right now is the project, and it's due on Thursday, the 23rd of February. So far, I haven't got anybody asking me questions on the project, but I guess probably now that you've submitted homework 3, that could change. It's probably just juggling things from time to time. Okay, now today we're going to be moving on to present worth analysis. And in present worth analysis, we're using the lessons of the present worth method to make decisions between alternatives. So in the present worth method that you've been using so far, you're basically just taking cash flow quantities in the future and discounting them to the present. And now you're going to be comparing 2 different things and deciding which alternative is best. And what complicates things is that not all alternatives have the same useful life. And so these 3 methods that are listed here are ways for us to compare apples to oranges, so to speak. Now, before we get into those methods, I wanted to go over some important terminology that will help us in comparing alternatives. When you have options between equipment and you can choose only one of the alternatives, that's a mutually exclusive situation. And so, for instance, if you're going to buy a new car, chances are you're only going to buy one. And so if you have to decide between if you have to decide between a sports car and a minivan, you can't have them both. And so a mutually exclusive situation is where only a single proposal will be selected. Now, independent projects are when you can choose more than one of them. And in the case of an independent project, it may be that you have enough budget for multiple alternatives or that they don't rule each other out. So it's like, it's not that you can't be in 2 places at one time, but maybe you have enough resources that can be divided. When you're looking at options, one option that a lot of people sometimes forget is the do nothing alternative. And very frequently, doing nothing is the best choice. And when you do nothing, that the current costs stay the same and nothing new is initiated. Some of the alternatives that we can decide from will be alternatives that generate additional revenue for us. And those revenue-based projects are going to have both inflows and outflows, whereas a cost-based project, which are typically undertaken in the public sector, would only have expenses. And so they may not have revenues coming in, or they may have just negligible revenues, but they have different outflows. And so a case of a revenue-based project could be when Apple's deciding to launch a new device, like a smartwatch, because that's certainly going to generate inflows to them, and so it's likely worth the development costs and the costs of fabrication and machining. All of the expenses that they incur is going to be offset by revenues in the future. But Apple wouldn't undertake a project that only had costs and no return. But a lot of public entities, like your parks department, may choose to put in a new swing set for children who aren't going to necessarily pay to use the swing set, but That's just an illustration of a project which would only have expenses and no revenue. Now, in the present worth analysis, what we're having to do is decide from multiple options, sometimes 2, sometimes 3, it can be even more. But our approach here, the method, is that we discount everything to the present at the minimum attractive rate of return. And that will either be a policy decision that's driven by the organization, or in the case of a homework assignment, you're given the interest rate that you should discount all of the future revenues to the present with. If a project is mutually exclusive, then the decision criteria is you'd choose the one project that has the highest positive present worth. Now, don't skip past this idea of positive present worth, because if present worth is negative, then that means you're losing money, and you should instead choose the do-nothing alternative. If projects are independent, that means you can choose multiple projects, and then your decision criteria there is select each one of the projects where the present worth is greater than or equal to 0 at the minimum attractive rate of return. And so if you've discounted all of the future revenues to the present, and your minimum attractive rate of return is that rate of return that's the least you're willing to accept, then a present worth of 0 would indicate that you're only making the minimum attractive rate of return. And if you've discounted everything at 7%, for example, and that's your MAR, if you've discounted everything at 7% and you have a positive present worth, then what that means is that this opportunity is going to make more than the minimum attractive rate of return. It means that even when you discount at 7%, there's even additional profits beyond that. So this is our method and our criteria, how we know whether to give thumbs up to a project or thumbs down to a project. And when you're solving a problem, you don't just solve for the numerical answer in present worth analysis. You also have to, with words, state what is the choice and what is the criteria you applied for the choice. And so your answer actually has 3 parts. So you may say, what is the present worth of option A? What is the present worth of option B? But you don't leave it there. You'd find both of the present worths for the 2 alternatives, and then you'd say which one should be selected, and then you should say why that's your answer. Like, what was the criteria that was applied? So maybe present worth A is $1,000, present worth of B is $500. You'd say, therefore, choose project A because it has the greatest present worth when discounted at the MAR. So the answer here has 3 parts: the calculation of the numbers, the statement of which to choose, and the rationale. All right. Now, the challenge with present worth analysis is that sometimes options have a different useful life. So here's 2 different cash flow diagrams that is illustrating the central conflict. If you have 2 options that last a different duration, then you have to make some adjustment to be able to understand which one's truly the most valuable. So you can't compare them directly if they have a different useful life. Because, for example, option B is lasting longer than option A. So even if you have more revenue in option A for each year, option B is lasting longer, and you could calculate the present worth of each of them, but it wouldn't give you insight into what's happening during year 7, 8, and 9 if you had selected option A. So the rule is, if they have a different useful life, you can't compare them directly. You have to overcome that discrepancy with some technique. So does everybody understand that so far? What we're going to be doing is talking about 3 different methods for overcoming the discrepancy in the useful lives here. And the first of them is called the least common multiple approach. And so look at what has happened from the base options, option A lasting 6 years, option B lasting 9. And now in the LCM approach, what we've done is we've repeated the cash flow diagram multiple times. Oh, wait, this is kind of jumping around a little bit. Computer has a mind of its own. So in the base case, it was 6 years versus 9 years. But after we've repeated the cycles 3 times for option A and 2 times for option B, you'll notice that both of them terminate after 18 years. And so now they have the same study period. So the length of the study period has to be the same to be able to compare options with the present worth method. And so what we did was we repeated each of them by purchasing the item another time. And you'll note that we didn't purchase the item a 4th time in year 18 because each cycle begins with a purchase and then has subsequent years of revenue. And so look, when do you have to purchase the item again for a second time? It's not in year 7, because if you purchase in year 7, you don't get revenue again until year 8. So there would be a gap of a year where the equipment wasn't available. So you have to purchase the item again in the last year, in year 6, in order to have that equipment available in an unbroken 18-year horizon. Okay, so we repeat the cycle 3 times for option A, twice for option B, and now we could find a single lump sum present worth and compare option A to option B. And that's what we're going to do for our first in-class exercise. But the assumption here when we apply the LCM method is that it is possible to purchase the item again, and that there's additional items available to be purchased, and maybe it'll be the same cost in the future, maybe it won't. You'll notice that here we've assumed that the prices didn't go up when you're purchasing it in the future. You could adjust that. You could say maybe $12,000 in the second cycle and $13,000 in the third cycle. But sometimes the item just doesn't exist anymore. Like, for instance, Boeing just this week made its last 747 jet, and they'll never make another 747. So if some company was assuming that they were going to be able to purchase that again in the future, they wouldn't be able to buy a new one. They'd have to buy it maybe on the used market. So the repeatability assumption just assumes that the item will be available in the future, and if it's not available for the same cost, then you could figure out what's the new cost in the future, or you could apply this approach by finding a substitute item and having the cash flow diagram reflect that substitute item. But somehow you have to have the cash flow diagrams end at the same number of years. So that's the main thing we're trying to achieve. It doesn't necessarily have to be that the second and third purchase are exactly an identical item. It's just that the study period for the 2 alternatives have to be the same. The other thing to ask yourself is, will the future revenues and costs be the same in the second cycle? Maybe they will. Maybe the revenues and costs will be different, and you can adjust your cash flow diagrams accordingly. Okay, so let me hand out the in-class exercise that we're going to start this with. No, that's the homework. Okay, so for this one, you'll see that it's what we've just been looking at. We've got $5,000 of revenue if we make this initial purchase. And so what I'm asking you to do is get some practice here. First of all, starting off by sketching the cash flow diagram right there on the paper. So it'll reinforce the muscle memory to you of when the item should be purchased another time, and not purchasing it in the year 18, which is a common mistake I've seen a lot of people make when they apply the least common multiple method. And this is at 4%. The 4% table is on the second page there. And so I suggest, I know that we used Excel in class previously, but let's do this one by hand. It's going to be relatively simple because what you'll have is an annual series and then two isolated future amounts that need to be discounted. So find out the lump sum present worth of option A versus option B. Okay, so up here on the whiteboard, it's showing the steps to calculate the present worth for option A. Is first of all, there's already 11,500 at the present, so no factor has to be applied there. But then take a look at the minus sign. It's because it was that arrow downward. That's an outflow. It's an expenditure. And then we have the plus sign because of the revenue, the $5,000 each year for 18 years. We have to multiply that by 12.6593, which is the discount factor for an annual series, which lasts 18 years at 4% interest. So it's that factor multiplied by 5,000. Revenue was plus. This next two terms are minuses because it's the second purchase of the item for 11,500 and then the third purchase of the item for 11,500. So one of them was in year 6, one of them was in year 12, so we've got different discount factors for each of those. And if you do all of those numbers, let me bring it up on the TV screen. What you should get is the present worth of alternative A is $35,525. And then for option B, we go through the similar process of there's a certain amount that's already at the present. So there's already the first cost of $16,200. So there, that minus is there. Then we've got the revenue discounted to the present. Same factor of 12.6593. This time the revenue is lower though. It's only $4,100. And we only have to repeat purchasing the item in year 9 a second time. So it's not in year 10. We need to make sure it's an unbroken stream of revenue through the entirety of the study period because that's what it takes in order to have the item in service during the entire 18 years. So we have to purchase it in year 9, and so we use that discount factor of 0.7026. And option B is 24,321. So this is not yet concluded, though, the analysis. The analysis is to find the present worth of each of the items over the same study period, and then to identify which of the alternatives to select. So we should write, therefore choose option A because it has the higher present worth when the revenues are discounted at the MAR. So our MAR was 4%, and the decision criteria for this mutually exclusive project, we have to either do option A or option B. Either one of them is potentially acceptable because we have a positive present worth when we discount things at the MAR. But since it's mutually exclusive and we have to pick one, the better of the two options is option A. So any questions about the LCM method? So who could restate the reason why we apply the LCM method? That's a concept question that you could see on the exam. Like, the question on the exam might be, why is the LCM approach used? What's the underlying need for LCM?
The LCM approach is used because you cannot compare apples to oranges. And what I mean by that is not all projects have the same lifespan, so you apply the least common multiple to make them the same lifespan, kind of like when you're adding or subtracting fractions, so that you can compare them in a similar fashion.
Good. Thank you very much. That's an excellent summary. That's exactly right. What we need to do is to compare two alternatives, they have to exist over the same time frame. Otherwise, we can't compare them. they have to last for the same duration. And here we've got an item that lasts for 6 years being compared to an item that lasts 9 years. So without LCM or some other technique, we wouldn't be able to compare these two options. But this happens all the time in the real world. You may have one computer system with a 6-year warranty, another computer system with a 4-year warranty, and you want to know which is the most economical. And so in order to do that, you'd have to use some technique to make the study period the same. And LCM is just one of the 3 techniques that we're going to talk about. So are there any questions before we move on from LCM to some of the other methods?
I have one question.
Okay.
Like we have the value of A for the 9th year, right? And for all the years up till 6, right? Why are we multiplying it with all the years on the cash flow?
So you're saying why are we using this P/A discount factor?
I don't understand that. Why are we multiplying the value of A with all the years, like all the
Oh,
years?
the 4100?
Yeah, with 18 years.
Because it goes, when you apply the LCM method, we're assuming that when you buy the item again, that the revenue continues through the entire study period.
Okay.
So if you buy it in year 0, you get revenue through 6 years. If you buy it in year 6, that gives you more revenue through year 12. If you buy it again in year 12, that gives you the revenue through year 18. And so if you look at it as a whole, then the annual series goes all the way through the 18th year. Yeah. Thank you for that question. Are there any other questions about LCM? All right. So remember that an analysis means that you're comparing alternatives and you need to state the decision criteria in your solution. Do you have a question?
Yeah, and it's not necessarily about the LCM, but it's about this. So we're choosing an alternative with the highest non-negative present worth, or we're choosing an alternative with the highest present worth, to determine which one's going to be more beneficial. But like you talked about in the beginning of class, where not all projects have cash flows,
Yeah.
how would you, like say Huntington wanted to build a park, and
Yep.
you're gonna have social, economics there, social benefit to the community, or they wanted to improve the levee system, which is not gonna have direct cash flows, but if you have a flood, it's gonna have it. So then, say those projects cost the same, where's your decision criteria?
Yeah. So that's a really great question. Methods like this, present worth analysis, can only be used for revenue alternatives. It can't be used for cost alternatives where there is more outflow than inflow. There are other techniques that we use to decide whether or not to undertake something like a levee system. Benefit cost analysis is one of the main ones. And the thing there with benefit cost analysis, you try and assign some dollar value to recreational opportunities. You assign some dollar value to the flood damage that's been avoided. And then you compare the benefits that you're going to get from a project to the costs that you're going to experience by undertaking it. And if the ratio of benefits to cost is greater than 1, then you'd go ahead with the project. But you're absolutely right. We couldn't calculate this and apply the criteria because I told you choose it as long as the present worth is positive. But there's plenty of projects, public work projects in particular, where the present worth isn't positive. It's just a lot of costs, and then people enjoy it, or maybe it's prevented some damage, but it's not necessarily profits. So this method can only be applied to, if we go back to these different types in the terminology, Excel just is, it's really locking up. We can only apply present worth analysis to revenue projects and not cost projects. That's another great question. Thank you for that. Are there others? All right. Well, LCM least common multiple. It's not the only way to get a study period that has the same duration. It's one way, but another one, this is our problem again. Our problem is that they don't have the same amount of time. Well, one way that we could have the same study period is we could rent the thing after it wears out. So option A, it wears out after 6 years. We could go and rent the item for 3 more years, and we'd have to pay an annual rental fee, but it would be in use during that period, and then we could just give it back to the rental agency at the end of the 9 years, and we'd have a cash flow diagram with the same duration. So this is illustrating what we call the contract services approach. It's just that you can either lease or rent or find some subcontractor to offer the item that you need to make the shorter of the two alternatives longer than it was before. So what contract services does is it lengthens the shorter of the two cash flow diagrams. So option A was the short one. We can lengthen it just by assuming we can rent some substitute equipment in year 7, 8, and 9, and now compare the purchase of option A followed by the lease of option A over a total of 9 years. Compare that to the purchase and implementation of option B. And then we'd find out which one has the highest present worth, and we'd choose the alternative with the greatest positive present worth.
How to assume that value, like 4,000?
We'd have to call and get some quotes. Yeah, here, there's nothing magical about 4,000. I just said, what if we found some agency, instead of having to buy it for 11,500, what if someone was willing to rent it to us for a certain amount each year?
It's like an assumption we can even take 13,000, like 4,500 each.
I'm sorry, I don't understand. Like, it's not necessarily 4,000. It could be something other than...
That's what I'm saying. If instead of 4,000, we are going to select 4,500, and its total would be like 3,500.
Oh, so you're saying the net.
Yeah.
Yeah, well, when you do the calculations, you can just find the net difference between them. But the illustration here, what I'm trying to illustrate is that you have both a cost of acquiring the item and then the revenue that you'd receive for operating it. So when you do the calculations, you don't have to necessarily discount this annual series separate from all the rest of it. You could say, let this annual series be through year 6, and then you've got a separate annual series where it's only 1,000 each year.
Okay.
Yeah, that's okay. Mm-hmm. Ben?
Would it be, is it okay for us to say we had a problem like this on an exam or homework or something? Is it okay for us to assume the least common multiple method, or assume this and assume a renter's value?
I'll tell you how much it'll cost to rent.
Okay.
And so you'll know which method that you need to apply if I tell you, for example, how much it costs to lease and operate, and yeah. I don't think there are any problems where you have your choice of which method to apply. But in the real world, you do. Yeah. Okay. So this little irregularity or difference in option A is because we're leasing the item for the remainder of the study period to make them the same length. So now they have the same useful life and can be compared on the present worth basis. Okay, so let's do the calculations, excuse me, for that one. And maybe we should use Excel for this one. Does everybody have their computers today? Looks like it. Yeah, just to, we got some practice doing it the hand calculation way, but let's do it now with Excel. Translate the cash flow diagram to a cash flow table on Excel. Again, we're doing 4%. Now in year 7, 8, and 9, you can just make it the net revenue. So the net revenue will be the difference between the inflow and the outflow.
Dr. Wade, if we were doing this by hand, for years 7, 8, and 9, what would be the easiest way to get those 3 years to a present value? I know we kind of already covered it, but I'm a little fuzzy on that.
You could do just 3 separate find P given F calculations. That's fine. Or you could do find P given A for 3 years, which would take it to year 6, and then you discount it as a single amount in year 6 back to year 0.
That makes sense.
Either one of those.
But here we like go with LCM, so that's why the value is different. Okay, it should have to be same.
Now, many of you have the same calculations as me so far. If not, that's okay. This video has all of the formulas and everything, so if you need to go back and watch the video after class to see how each step was calculated, it's there. But we're not done yet. Like if the question was, which alternative is better, we haven't yet answered that question. Because to be a complete answer, it needs a statement of, you don't leave it to the grader to interpret your work. You interpret your work. And so we'd write a statement here, thus option A should be selected. And then what's our decision criteria? because it has the higher present worth when the future amounts were discounted at the MAR of 4%. So, to be complete, the answer has the calculations, the interpretation, and the decision criteria that was applied. All right. So that's contract services. Remember what contract services did is it lengthened the shorter of the two options. Because our overall objective is we can't compare two options if they have a different service life. We have to make the study period the same number of years. And so LCM repeated to make it the same number of years. Contract services lengthened the short one to make it the same number of years. And then the other method that we're going to have, called early termination, will truncate or shorten the longer of the two cash flow diagrams. So we're just trying to make them the same length. Before we move on from this second part of the in-class exercise, are there any questions about this example? Okay, well, then, if that was contract services, let's talk about early termination. Option A is too short. Option B is too long. So what we could do is, instead of keeping it for the full 9 years and then throwing the item away when it's all used up, we could sell it on the open market at the end of 6 years, and whatever value it has remaining will be added onto our project as a single lump sum. So this green arrow here is the lump sum equivalent of selling the item. Instead of having revenue in year 7, 8, and 9, we'll find someone to buy this equipment for us, and we're going to take it as a single lump sum in year 6. So now they have the same useful life if we do that, and we can do a present worth analysis once they have the same useful life. All right, so let's try that out. Let's try the early termination instead of continuing the longer alternative, which was contract services. This time we're going to sell the equipment early, and then by foregoing those future revenues, we're basically exchanging those future revenues for whatever residual value the equipment has when we sell it in the last year. All right, so here's this same cash flow diagram that we've been looking at so far today. And if you turn the page on the paper, it has it's got resale value. And by the way, we've changed interest rates on this last one. For this last one, its interest rate is 10%. So let me help you interpret this table. What this table is saying is, if you buy the item in year 0 and immediately sold it back instantly, you could sell it back for $12,200. If you sell the item after only 1 year of operation, so at the end of the first year, it has a resale value of $14,400. So in each of these subsequent years, you can see the effect of depreciation. Like the equipment's value is decreasing because it's getting worn. It has less useful life. And so at the end of 9 years, it has no value. So I'm going to pause and ask you to apply the lessons learned here. Apply the lessons learned of you forego the revenue in year 7, 8, and 9, and instead replace it with an additional lump sum in year 6. Now look, year 6 still has its revenue, so it's got its revenue amount and the value of selling the equipment in year 6. So that's what we're going to do in this last part of the in-class exercise. Let me start a new tab down here at the bottom using the New Sheet button. And then what we're working with is this one. I'll paste it. We again have our interest rate defined at the top. It's this time 10%, so 0.1. and then we're going to have year, amount, PV of amount for option A, and then the same thing over here for option B. So we want to compare it over the same time frame, but this one is going to make it shorter. So we only need it through 6 years. Oh, I didn't anchor the reference to the interest rate. That is truly a noob mistake. How humiliating. And I'm going to post this on YouTube for the whole world to see that I forgot to anchor my reference to the interest rate. That's how you can tell someone who just either doesn't care or is really confident, is that they'll post their mistakes on YouTube. And I guess it's a combination of the both for me. I don't care if people watch this. All right.
But can you use Microsoft Excel without a mouse?
Oh boy, not well. It's not a pretty thing if I do that. Can you?
No.
Yeah. I guess there is a way to do it with keystrokes and what have you. All right, so in year 6, we've got the revenue, and also we're selling the item. That's the whole essence of early termination. We're selling the item, and we're going to get $5,400 for doing that. So it's a total of $9,500 in that year.
Why do we only add that in the option B?
Because option A is finished at the end of 6 years. Option A doesn't last for any longer than 6 years. It has no residual value. At the end of 6 years, option A is all worn out. This resale value only applies to option B being sold early.
Okay, then why are we not finding the option B till the 9 years then? Because we have to compare it with the 6 years in the option A?
That's right. To compare option B and A together, they have to be over the same number of years. This time I'm going to anchor the reference. So, by the early termination approach, just to finalize things here, remember it's not sufficient for us just to calculate these. We have to now interpret the results and say what's the outcome of our analysis. Thus, we should select option A because it has the higher PV when the amounts are discounted at the MAR of 10%. So we select option A. Now on the subject of mistakes, there's lots of ways to screw this up. Excel is a beautiful tool, but it's so unforgiving. Maybe ChatGPT will fix that. Maybe there will be AI that will help us to remember to include the minus sign or to put in the double comma. But think about all of the ways that we could have got the wrong answer. So for instance, what if I had forgotten the minus sign? So if I'd forgotten the minus sign, it would look like the present value is negative, because it would say, well, you've only got one revenue and then all of these costs. And so if we forgot that one little minus sign, it would tell us option A is not acceptable. Okay, so luckily that's not a mistake that I made. But what about, like, what if we don't have the double comma? I feel like maybe I haven't hammered this home yet. What it means if you put the amount in the payment field instead of the future value field. So, for example, if I didn't have that double comma, I will put the minus sign. Let's say I didn't forget the minus sign, but I did forget the double comma. So what is the mistake going to be there? Okay, now look what it's doing. It's saying 5,000 has a present value of 4,545. Okay, that's actually true. But now this next one, what we intend it to be is we intend each row to be treated as a single lump sum amount. But what Excel thinks, since we put that in the wrong field, it thinks it needs to calculate the present value of $5,000 repeated twice. And so it assumes that there's an annual series with 2 years and each of the payments is 5,000. So this 8,000 is the present value of 2 payments of 5,000. And it's like if you follow it through, 21,776, it is saying that is the present value of an annual series of $5,000 each year. So then if you add it all together, you're summing an annual series of an annual series of an annual series. So that extra little comma is really important, because otherwise what we've done is we found the present value of 6 different annual series and added them together. So make sure that if it's a single lump sum amount, like we're treating each one of these rows as a present value that is being brute force discounted to the present, it's a future value that's being discounted to the present, we need to have that double comma in there in order to do that. So it's important to understand the potential mistakes that could be made and what it'll look like if you make that wrong mistake. So if you forget the minus sign, what it'll look like is that you have one revenue and lots of expenses. But that doesn't match the cash flow diagram. What does it look like if you forget to anchor the reference to the interest? Well, it looks like that. You know, like the first one's maybe right, but then no discount, value, 0, 0, 0. Okay, something's not right. So you need to be able to be on the lookout for mistakes, because they're easy to make. It's 5:12. We've only got 3 minutes remaining. Are there questions on this early termination method? Let me show you the homework. Oh, did I hand it out already?
Yeah.
Okay, so you've already got the homework. There's a couple of problems. Problems 1 and 2 is just stuff you've already done, even before today's class. And then problem 3, you're doing present worth analysis, and these 2 different items that it describes, they last different years. And so you could do LCM for problem 3. Problem 4, you were given the information that you'd need for, let's see, 3 years, 12 years, 6 years. Oh, that looks like LCM as well. It's all conveniently multiples of 12. Problem 5, contract services. It says right there in the statement. Problem 6, contract services. Problem 7, early termination. Okay, so let's see, problem 8 is future worth analysis. We'll talk more about that later, but we've done present worth analysis, and just with today's information, I think you can get an early start on the first 7 of the 10 questions on the homework assignment. So, as you work on that, I'd be glad to have you stop by my office or call me on Teams or send me an email. I'd love to help you on this. I don't mean for you to struggle in vain. You know, there's answers to all the questions, and so just let me know how I can help, and I will see you in class next Tuesday.